My name is Maia Shwarts. I'm going to be doing a physics problem for you today. We have a 1,000 kilogram car 50 meters off of the ground on a hill, and I want to find the terminal velocity at this point. And what I'm going to be using, two equations are the kinetic energy of my vehicle and the gravitational potential energy of my vehicle. And I set up this nice long equation down here where I added together kinetic energy, gravitational potential energy, initial, velocity initial and height initial in that case, because kinetic energy is 1/2 mass times velocity squared. Gravitational potential energy is mass times gravity times height, and I'm using the gravity constant of 10 meters per second, or 10 meters per second squared. So I set up my equation 1/2 mass times final velocity squared plus mass times gravity times height final. Now right off the bat you can see that there's mass on all parts of my equation, so I can get rid of that quite easily. And since the bottom of my hill is at height of 0 and I am starting from a non-velocity position, I'm starting from stillness, I can take away velocity initial, making this 0, and I can take away my final height, which since that's 0, so I'm setting equal 10 meters per second squared times 50, which is the initial height, is equal to 1/2 velocity final, which is what I'm trying to find, squared. And that is 500, that's another meters, that's 500 meters squared over second squared, is equal to 1/2 velocity final squared. And 500 divided by 1/2 equals 1,000. Nice number. 1,000 is equal to my velocity final squared. All I have to do is square root the entire problem, and that is equal to approximately 31.6227, and I'm going to round that to approximately 32 meters per second. And I can say meters per second because here we have velocity final, which is going to be meters per second, and I have meters squared per second squared, and that all negates out nicely with my square root of 1,000 meters squares per second squared. And therefore, the answer is 32 meters per second, and that is how you find terminal velocity on a problem with a hill.